For this problem, we're given a rational function, and we're first asked to find the domain, and then use several steps to graph the function. So we have f of x is equal to x squared minus 9 over x minus 2. So let's first talk about the domain. We need to set the denominator equal to 0 and exclude any value that makes the denominator 0. So if we set x minus 2 equal to 0, we get x equals 2. So our domain is the set of all x such that x is not equal to 2. So any real number except 2. Now let's move on to the steps in order to help us graph our function. In step 1, we look to see if we have any symmetry. So we find f of negative x. F of negative x is equal to negative x quantity squared minus 9 over negative x minus 2, which is just x squared minus 9 over negative x minus 2. Now we have one of three possibilities. Either f of negative x is exactly the same as f of x, in which case it's an even function and it's symmetric with respect to the y-axis. That's not the case here, because the numerator is the same, but the denominator is a little bit different. The second possibility is that f of negative x is exactly the opposite of the original function f of x, in which case it would be odd and symmetric with respect to the origin. Well, let's see if that's the case here. If that's the case, we need every single term to have an opposite sign. Well, since both x squared and x squared in the numerator are both positive, then it's not opposite. So, therefore, we can say that it's not odd. Finally, we can say that there's no symmetry, so we'll say none. In step 2, let's find our y-intercept if we have one. We find our y-intercept by letting x equal 0. So that just means we're looking for f evaluated at 0, which in this case is going to be 0 squared minus 9 over 0 minus 2, or simply 9 halves. Let's see if we have any x-intercepts in step 3. We find x-intercepts by letting y equal 0, or in other words, we'll just substitute 0 in for f of x. And we'll set that 0 equal to the numerator of the rational function. 0 equals x squared minus 9. Well, that gives us that x squared is equal to 9. If we take the square root of both sides, we get x is equal to positive or negative 3. So we have two x-intercepts. Now we need to look in step 4 to see if we have a vertical asymptote. We find a vertical asymptote by setting the denominator equal to 0 in its reduced form. So we have already set the denominator equal to 0 when we were looking at the domain, and we did get a solution that x equals 2. So therefore x equals 2 is our vertical asymptote. Now in step 5, we want to see whether or not we have a horizontal asymptote. We find a horizontal asymptote by comparing the degree of the numerator to the degree of the denominator. We have three possible cases. If the degree of the numerator is less than the degree of the denominator, then we just have the x-axis, or the line y equals 0, as a horizontal asymptote. That's not the case here. The degree of the numerator is 2, the degree of the denominator is 1, so by looking at those exponents we can see the degree of the numerator is not less than the degree of the denominator. Well, the second case is if the degree of the numerator is equal to the degree of the denominator, and we get the asymptote just by taking the ratio of the coefficients. That's not the case here either. But we do have the third possible case where the degree of the numerator is larger than the degree of the denominator. Now notice the degree of the denominator is 1, the degree of the numerator is 2, so the degree of the numerator is larger than the degree of the denominator just by 1. If that's the case, we can use division to find what we call a slant asymptote. So we can use division, and in this case synthetic division will work since we're dividing by x to the first power. So let's use synthetic division. Since we're dividing by x minus 2, we're going to now, let me put a couple things here. We have no horizontal asymptote, but I'm going to use the abbreviation SA for slant asymptote. And we're going to do synthetic division to find out what that is. Since we're dividing x squared minus 9 by x minus 2, we'll put 2 that we're dividing by, and we'll have the coefficient 1 for x squared. We need to place a 0 for our x coefficient, and then we have negative 9. And when we do this synthetic division, bring down the 1. 2 times 1 is 2. Add 0 plus 2 and get 2. 2 times 2 is 4, and we have a remainder of negative 5. The remainder is really not important in finding our slant asymptote. This bottom two numbers right here, the 1 and 2, give us the information about our slant asymptote. And here it is. It's the line y is equal to, we take this coefficient 1 down here, 1x, and then plus 2. So simply the line y equals x plus 2 is our slant asymptote. Now the very last step that we need to do here is step 6, and we need to come up with a couple of points to help us complete our sketch. Before I go to step 6, I'm going to use the other information I have to help me. So we do have a y-intercept of 9/2. That's 4.5. We also have two x-intercepts, one at positive 3 and one at negative 3. And then we have a vertical asymptote, x equals 2. So let's sketch that in. We know there's no symmetry, but we also know that we have a slant asymptote that is the line y equals x plus 2. So that's simply just like the line y equals x shifted up 2 units. So now we want to choose values in number 6 when we plot points such that we have values to the left of x-intercepts, to the right of x-intercepts, and to the left and right of our vertical asymptote. Well, we can see right now if we choose a value to the left of negative 3, we could choose, say, negative 4 for x. So here's our chart with x and f of x. Let's let x equal negative 4. If we do that and substitute in our original function, we'll get the value negative 7/6 for our function. So negative 4, negative 7/6 is right about here. And we know that when we graph this and sketch it, that the graph will tend toward the asymptote. So we'll connect these intercepts and sketch that part of the graph in there. Now, we also can pick one value to the right of 3, our x-intercept. Let's pick positive 4. If I substitute in positive 4 in my original function, I'll come out with the value 7/2. And we can plot 4 7/2 is right about right here. About 3.5, and right about here. I didn't mean to draw that little dot right there, so we'll ignore that. And with the exception that that little dot shouldn't really be there, here is the sketch of this rational function.